Hello everyone, I'm João from That's Brilliant. In this video, we are going to use the Newton's second law of motion equation. We have another video in That's Brilliant, whose link I'm going to put in the description below, talking about Newton's second law of motion. And this law basically says that if we have a net force different from zero, we have acceleration. And in that video, we also saw this equation here. Force is equal to mass times acceleration. And as you can see, both force and acceleration are vector quantities. Mass isn't a vector. So the force has the same direction than the acceleration. So let's just use this equation to solve these three examples here. So let's go to the first one. We have an object of 2 kilograms of mass, and we want to know the necessary force in order to accelerate this body at a ratio of 5 meters per second squared. So it's the basic usage of this equation. So as you can see, the acceleration is going to be in the same direction of the force. So we're going to use that equation just using the magnitudes. So force is equal to mass times acceleration. So the force is what we want to know is equal to 2 times 5. And this is equal to 10 newtons. We saw in that video that the unity for force in the international system is newton. When we multiply kilogram by meter per second squared, we have as a result newton. So the answer to the first exercise for the first example is 10 newton. Let's now solve the second, the red example. So we have a body in which we have applied two forces, and the forces are in the same direction. So we know that the net force is also in this direction, to the right. And let's just call the net force of F. And we're not going to I'm not using the exactly correct lengths to the vectors. It's just a simple way to represent the vectors. So as we know, the net force is the vector sum of F1 and F2. So we know that F, just using the magnitudes, is equal to 2 plus 3. So F is equal to 5 newtons. The net force is equal to 5 newtons. And to use this equation is using the net force. So we have to calculate the net force. So F is equal to mass times acceleration. So 5 is equal to mass is 1 times acceleration. So now we discover the acceleration. The acceleration is equal to 5 meters per second squared. And now let's just solve our last example of this video. We have another object in which we have applied 3 different forces. And as you can see, these forces have different directions. So we need to say which direction is the positive one. Just for us to know the correct signals of the vectors. So we have to say which is the positive. You can choose. Let's choose the same direction we use in the other examples. To the right is positive. And let's say that in consequence, to the left is negative. So let's calculate the net force. The net force, let's call it of F, is equal to the vector sum of F1, F2, and F3. So we can see that F is equal to, let's think, F1 is to the right, so it's positive. But F3 and F2 are to the left. We are considering to the left is negative. So it's going to be minus F2 minus F3. Here we are just considering the magnitudes. So we have to use a direction of positive and a negative direction in order to use the correct signals here. So as you can calculate here, the magnitude of the net force is equal to 4 minus 3, 1, minus 5, negative 4 Newton. So our net force is to the left. Why? Well, the value of the net force is negative. This means that the net force is in the direction that we consider negative. So it's the negative direction. So it's to the left, the net force, the direction which we considered being negative. So the net force is to the left, and in consequence the acceleration is also to the negative. So just to consider the right direction here, let's just put the negative signal here. This is telling us that the acceleration is also in the negative direction, is also to the left. So now we can solve this exercise. So F, the net force, is minus 4, is equals to mass, is what we want to discover here, mass, times the acceleration, minus 2. So multiplying both sides by minus 1, everything goes positive, and you can see, dividing both sides by 2, that mass is equal to 2 kilograms. And this is the value of the mass, 2 kilograms. If we have considered to the left as positive and to the right as negative, we're just going to have opposite signs that we have. So the acceleration was going to be positive and the net force was going to be positive. We're going to put here F2 plus F3 minus F1 as the net force, and we're going to have the opposite signs that we have here. So any questions, please leave them down in the comments below. Thanks very much for watching, and I see you in the next videos.